Hey math enthusiast, I'm here to continue the notes on section 1.1 dealing with points, lines, and planes. So now that we've defined a point, a line, and a plane, there are some other terms that follow. The first being collinear. Collinear is points that lie on the same line. So, for example, what we drew earlier in the section, you might have a line. Now remember, a line is defined by 2 points. So any 2 points are going to lie on the same line. When I'm talking about collinear points, I'm referring to at least 3. So in this case, I would have to add a third point to show that these 3 are collinear. They lie all on the same line. Easy way to remember that is inside collinear is the word line. Now over here on the right in this last column, they want a counterexample. What I mean by a counterexample is an example that is false. All right, that shows me 3 points that are not collinear. Well, if I want 3 points that are not on the same line, let's say I start off with A and B like we had before, but instead of putting C somewhere where it's going to fall on the line, like I had it to the left, I'm going to place C down here. So in this case, there's not one line I can draw that would connect all 3 of these points. I can connect A to B, I can connect B to C, and I connect A to C, but I can't have one line connecting all of them. Our next term, between. Pretty self-explanatory. All right, if I have 3 points on a line, then there is one of them that's going to be between the other 2. So if I want to redraw the picture from up above, we have points A and B on the left and the right. And in this case, the point that's between would be, obviously, point C. Now, once again, a counterexample of that would be just a case where the point is not between the other 2. So I could actually just redraw what I have right up above. So if I have A, B, and once again, C. All right. So for it to be between, it has to be on a line. All right. In this case, A, B, and C are not on a line, so it's not between. And my last term, coplanar. Very similar to collinear from up above. This is just points that lie in the same plane. So what I'm going to do is I'm going to sketch out my plane. Remember, it's kind of like that parallelogram. And I'm going to add some points. Now, collinear, it has to be at least 3 points. All right. Well, remember, a plane is defined by 3 points. So any plane I draw, it should have 3 points on it. So when I'm referring to coplanar points, it's going to be at least 4 points, because every plane already has 3 points. So I'm going to add another point to my picture. So in this case, A, B, C, and D are coplanar. As for my counterexample on the right, I'll sketch out my plane, add my initial points, my 3 points that define this plane, which let's say are A, B, and C. And then I'm going to have a 4th point that is not on the plane. So we can put it down here, somewhere else out in space so that it's clearly off the plane. So these 4 points that I drew all together are not coplanar. They're not coplanar. So let's take a look at a couple examples that use these terms. So for the picture on the right, first thing they want is other names for line LN. So let's find that in our picture. Here's line LN, continues on forever. Okay, so the points that lie on it are obviously L, N, and M. Well, if you want to rename it, you could just say NL and use that symbol up above to tell me it's a line. Or I could use one of the other points that I haven't used. So you could say LM, for example. Or you could say MN if you want. Or if you want to, you can use the word line in front and any 2 points that lie on it. So I could just say line LN. The other thing I want you to notice is that you can use that lowercase letter at the end that I mentioned before. All right. In this case, it's not cursive, but it is that single letter that's clearly not a point because it's not capital, it's not bold, it's not the name of the plane. So I could use that to name my line. So if I want to, I can just call it line B. For number 5, they want another name for plane Z. They're using a single letter to name it, so it's this bold capital letter in the corner. There's no dots around it. It's not a point. So instead of calling it plane Z, I can name my plane using 3 points that lie on it. So I'm going to start off with plane, and I'm going to pick out any 3 points I want. So we can say L, P, M if you want. You don't want to use those letters. You could switch it up and say L, M, N if you want to. Any combination of essentially those 4 points that I've highlighted here. For number 6, now we come across that term collinear. So they want 3 points. Remember I said collinear is at least 3 points. So I want points that lie on the same line. There's really only 2 lines drawn in my picture. Either dealing with this vertical line or this horizontal line. Well, there's only 2 points on the vertical line, M and Q. So that one's out. So let's focus on the horizontal line. So my 3 points would be L, M, and N. As I said, you can include the word point if you want, but you don't have to. You can just put down those 3 capital letters and it's understood that you're referring to points. For number 7, they once again want some other names for this line, so this vertical line that I highlighted earlier. 2 other names. So, if I want to, I can just reverse the order. You could use the word line if you want, instead of the symbol. Line MQ, line QM, or you could use that lowercase letter down at the bottom of your line and just call it line A. For number 8, we come across our other new term, coplanar. So I want 4 points coplanar that lie on the same plane. There's only one plane in my picture. So I just want to pick out the 4 points that lie in that plane. L, M, N, and P. Now I'm not going to include Z because remember that's not a point. There's no dot near Z. Okay, remember that is the name of the plane. And then for the last one here, they want a point that's not coplanar with these 3. So they're referring to L, N, P. So 1 point that's not on this one plane here. So obviously it would be point Q, which is floating up above. So if you want to write point Q, you can, or you could just write down Q. Now we have some new terms that build on our initial undefined terms. The first one being a segment. So this is only part of a line. It has endpoints. It does not continue on forever. So for example, let's say I still have A and B, but instead of drawing my line past them, I'm just going to go straight from A to B. I'm not going to go outside of them. I'm not going to include arrowheads because it does not go on forever. As far as the name goes, I can just use the 2 points that make it up, AB, or you could say BA if you want. And notice the symbol that I'm putting up above does not have arrowheads. I'm also not including like little endpoints on the end because it's unnecessary. All right, it either has an arrow or it doesn't. In this case, it doesn't, which tells me it's a segment. It does not go on forever. The other option is, if you want to, like we did with line, you can write out the word segment and then just name it by its endpoints. So you could say BA or you could say AB. Next term we come across is ray. Now if you remember when you guys were younger, draw a little picture with your sun up in the corner like this, maybe put some sunglasses on it or something, and you would include these little lines coming out. All right. That is essentially a ray. Okay, it's part of a line that consists of a point, an initial point, so that would be my sun up here in the corner, and all points on the line that extend in one direction. So here's my sun ray coming out of the sun, continuing in that one direction. So if I were to draw it like we might see in our textbooks or examples, I would have my 2 points that define it. Let's say CD, starts at C, goes to D, and it continues to go in that direction. As far as notation and naming it goes, I'm going to call it CD, and up above for the symbol I'm going to use this. Okay, notice it has one arrowhead. All right, and that arrowhead is always going to be pointing to the right. It doesn't matter which direction my ray is going. All right, that symbol that I'm putting up above is just to tell people this is a ray. Now in this case, I don't have the option like I did up above. I can't call this ray DC, all right, because the first letter I list is the starting point. In my picture to the left, I started with point C. So when I name it, it has to start with that initial point. So ray DC is a different ray that's not pictured here. Your other option, obviously, like we had up above, you can just use the word array if you want, followed by the initial point and the other point that makes up your ray. Last term is opposite rays. Okay, so this would be 2 rays that share a common endpoint, and they have to form a line. So I'll start with this point in the middle, point E. And let's say we have one ray going this direction, point F. And we're going to have another ray going the complete opposite direction, G. Okay, notice that these 3 points together are collinear. They all have to lie on the same line to be considered opposite rays. So now when I name them, there's a couple parts I have to name, all right, because we have ray EF going down to the left, but I'm still going to use this symbol pointing to the right, and ray EG going up to the right. All right, notice both of them have the same initial point. All right, that makes them opposite rays because they share a common endpoint. Obviously, my other option with naming them is to use the word ray. So you can say ray EF and ray EG. So let's take a look at a couple of these examples. Now for number 10, I actually changed this problem to name all rays with endpoint B instead. So I'm focused on B. So when I name my rays, that's obviously going to be the first point I list. So we could be going down to the left. So that would be BA. I'm going to use my symbol up above. My next one is obviously going to start with B, going up to the right. So that would be BC. Or we could be going down to the right, BD. All right, all of them start with B because that's the end point. For the next example, we want a pair of opposite rays. So you have to be going in complete opposite directions. So it looks like A, B, and C are collinear. So that's the other stipulation, has to be true for opposite rays. So in this case, my 2 opposite rays would be BA and BC. They're collinear, they form a line, they share an endpoint, so therefore they are opposite rays. For 12, 3 non-collinear points. So in this case, I'm looking for points that are not on the same line. Well, obviously I don't want to use A, B, and C because those are clearly collinear. They lie on the same line. So how about A, C, and D. Those 3 points together, I cannot draw one straight line that's going to go through the three of them. All right, obviously another option would be A, B, and D, you could say. Or you could go with B, C, and D. All of those would work. For the next example, I want to name two line segments that are not on the same line. So remember, your line segment has endpoints. So we could go with, start with AB. And remember, I'm going to use my symbol for segment, which does not have arrowheads. Doesn't have endpoints either, it's just that flat segment up top. And as far as being not on the same line for my other segment, let's go with CD, because it's not even touching AB at all. Okay, CD, and then my symbol up above. For 14, I want two rays that are not opposite rays. Okay, so we defined opposite rays earlier in 11 with BA and BC. I'm still going to use BA actually as one of my rays, but the other ray I'm going to list is BD. Now, even though they do share the same endpoint, B, the thing is they're not going in complete opposite directions. When I trace them, it does not form a line. The 3 points B, A, and D are not collinear. 15. Are AB and BA the same ray? Let's start off with AB. So remember, A is your initial point, then it goes to B, and it's going to keep going in that direction. So I'm going to have my arrowhead up here. As for BA, now B is your initial point, goes towards point A, and then it's going to keep going in that direction. All right, so there is some overlap right here in the middle, but the problem is the one keeps going in one direction while the other one keeps going in the opposite direction. So in this case, the answer is no. They're not the same ray. And the last question is very similar. We'll start with ray AB. So I'm going from A to B, and I keep going that direction. And then ray AC. I'm still starting at point A. Now I'm going to point C, and I'm going to keep going in that direction. In this case, my rays have the same initial point, and they're going to completely overlap. Remember, this red ray is going to keep going in this direction. So in this case, the answer is yes, they are the same ray. Last couple examples in this section have me sketch out a couple pictures. First one is 3 lines that intersect in 3 points. So let's say I have one line here, and I'll draw another line that's intersecting that. So these two intersect at this single point right here. But I want 3 lines that intersect at 3 points. So instead of drawing another line going through this point of intersection, let's go with a line down here that intersects these 2 other lines at different points. So now I have 3 lines and 3 points of intersection. For 18, 4 non-collinear points, A, B, C, and D. Right. So they just have to not be on the same line. So let's have A and B, C up here, and let's say D down here. So I cannot draw one line that's going to connect those 4. So they are non-collinear. Then we have some connections to make. So first we have segment AB. So it's not going out of outside of A or B. Then we have ray BC. So this goes from point B to point C, and it's actually going to continue. So I'm going to add a little arrow there. And the last one is line AD. So I'm going to draw a line going from A to D with arrowheads on either end. So I have my 4 non-collinear points, I have my segment AB, and my ray BC, and my line AD. My final example deals with one line that lies in a plane and one line that does not lie in the plane. First, let's start with our plane. All right, you can call it whatever you want. I'll put a bold capital A down here for plane A. And I want one line that lies in the plane. So let's say here are my 2 points that make up that line, B and C. And I'm going to show that this is clearly, and I want to show that this whole line is clearly in the plane. Now you might be thinking, well, if you draw an arrowhead here, doesn't that mean that this line is going to continue outside the plane? Well, remember, the plane continues and extends without end, much like the line. Next thing I need to add, though, is one line that does not lie in the plane. So let's draw another line over here. And I'm going to clearly put it away from the plane to show that it's not near it, it's not in it clearly, and it's definitely not going to intersect it. So we have line DE that is not in the plane, and then you have line BC that clearly is in the plane.